In this video, we're going to be talking about the fourth law of indices. We've talked about the first law, second law, third law in our previous video. Now we're talking about the fourth law. I'm going to teach you how to apply it. It's a very simple thing. Let me start with this x raised to the power 1. What it simply means is that we are going to say 1 over this number. Look at this number, look at this number. Can you see the number? X raised to the power 1. I'm going to remove the minus sign. It's still the number. I've not changed anything either. But in mathematics, we don't normally write raised to the power 1 because we know that s is the same thing as s raised to the power 1. In this table 1, nobody tells you that. It's expected that you know that s raised to the power 1 is the same thing as s. But I'm explaining, that's why I'm writing it there. I will leave it there all the same to my explanation purpose. X raised to the power 2, what it means is, don't forget, this is the number, x raised to the power minus 2. I am removing the minus sign with this same number. I've not done anything, this is just the law. And don't forget that this one, what you have here, like I said in my previous video, you should be able to take it back and forth, back and forth, back and forth. This one is equal to this one is equal to what? This. Understand that very, very clearly. Let me give you the last of them I would like to talk about. Let me say a raised to the power 2. What it simply means is 1 over a raised to the power what? We've not done anything. This is just the law. It's just the law. We have these things applied in physics that so many people do not understand how those units play out. For instance, we normally say in physics that meter over seconds is the same thing as meter raised to the power meter seconds raised to the power minus 1. This is what is happening here. Let me explain what is happening. This is it. Just the fourth law of indices that you are seeing there. What we are having here is something like this. 1 over what? X is 1 over x. So what this one means is something as what? Meter over seconds, which we normally call meter per second. It's the same thing. You can see where it's coming from. It's an application of what? The indices, fourth law of indices. That's how we normally write either meter per second or meter seconds raised to the power minus 1. The same thing applies for the unit of, this one is the unit of velocity or speed. Then the same thing applies for the unit of acceleration, where we normally write meter per second squared. Sometimes we write it like this, raised to the power minus 2. It's either like this or like this. In both cases, you are right. What is simply happening here is the fourth law of indices. N times 1 over S2, like I did here. Check it. You'll see it. So we now have meter over second squared, which is the same thing as what? Meter per second squared. This is the unit of acceleration. So it is clearly spelled out that these laws are applicable everywhere. So I'm just using this one as an example. We have other ones that we apply it. Even when we are writing the unit of pressure, we're writing the unit of linear expansivity and all that in physics. But we're not in physics now. I'm only trying to show you some of those units in physics, how these laws of indices are applied. This is just the fourth law. I will go to the fifth law now. Fifth law. The fifth law. In the fifth law have made some work very easy for us. Fifth law. Fifth law have made something very easy for us. Like now we have maybe y raised to power 5. Example, maybe I don't know, some example 7 if I'm not making a mistake. So from our following up from our previous video, we have something like this. What it simply means is x raised to the power 2y. That is occurring 5 times. That's what it means. But that's not what the law is telling us. But I want to explain it from here so that you understand the reason why we are using the law. Let me first of all do this like this. X raised to the power 2y. X raised to the power 2y. 1, 2, 3, 4. Then x raised to the power 2y. So you can see it's 5 of them. That's what this one tells us, raised to the power 5. Like I said earlier, don't forget AB exactly as what? A times B. AB means A times B. So the fact that we're writing A squared Y does not mean that it's not A. It does not mean that it's not S squared times Y. It's the same thing. That's what we're talking about. So if you check something very important here, you discover that in all, they are all in multiplication form. All in multiplication form. And they have similar base here. X, 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 X. As long as we have that, we can apply our first law here. Our first law that tells us that similar base 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5. You can see 1, 2, 3, 4, 5. That is for X, similar base. They will now say Y. Invisible one. Nobody tells you that there's one there. But you should know that. That is mathematics for you. 1 plus 1 plus 1 plus 1 plus 1. When you do that, you're going to have something like this. X raised to the power 10, Y raised to the power 5. This is exactly what you have. We have not applied the law yet. I'm only explaining what you are seeing right there on the board. Normally in mathematics. But the application of the law made life very easy for us. This is where the application comes. In the application of the law, this is Y raised to the power 5, right? What the application of the law tells us is just simply this. We multiply the power outside the bracket with the individual power in the bracket. The power outside the bracket with the individual power in the what? In the bracket. 5 times 2 will give us what? X raised to the power 10. Invisible one is here. Nobody tells you that, like I said earlier. 5 times 1 will give us what? 5. So this is where we apply the law. So the law has made the work very easy for us, not going through that Israelite journey of trying to represent it the exact way it comes. We have to go through these processes before we can get it. No, the law has made it very easy for us that we can multiply through the power. That's exactly what we are seeing there. If you find this video very interesting, try to subscribe to our channel. Try to watch other videos I will post it. Thank you very much for your time.